Okay, so let's look at the integral from 1 to 4 from x squared minus 4x plus 2 dx as a starting point. So where do we start? How do we think about this? What do we do? We have to determine the function what? How is this called? And yes, uppercase F, which is the antiderivative. Perfect. Yes. So what function prime is x squared? Minus 4. What function prime is x? What function prime is 2? 1 to 4. Do we understand? We agree. So I'm going to simplify here and get the 2x squared. Do we agree with this first step? Everyone? Perfect. So now I would have to replace x by 4 and subtract when I replace x by 1. So 64 over 3 minus 4 times 4 is 16, 16 times 2, 32, plus 8, minus. I plug in 1. 1/3 minus 2 plus 2. I have to perform these operations. First of all, these 2 go away. Then I have 64 thirds, and this is minus 24, and minus 1/3. Well, luckily, this changes into 63 over 3, which is 21, minus 24, which is negative 3. Is this okay? I would like us to talk a little bit about the following function. So the function is natural log of the absolute value of x. We will go back to the absolute value of x first. That's our starting point. And you will tell me what the absolute value of x equals to. Yes, awesome. If is, say it again. Good. And the other option is? Very good. When x is? I cannot put the equal symbol in both. It's not a mistake to put it in either, but it's a mistake to put in both. Good. Perfect. That's what we have. Now I would like us to simplify this function, which is natural log of the absolute value of x. What are the options? Very good. Awesome. I cannot have 0 in a log. I can have 0 in the simple absolute value, but not in log. We agree? Good. What is the other option? For x. Excellent. Now I want us to find f prime. So natural log of the absolute value, prime. Very good. What about the second one? Yes, 1 over negative x multiplied by negative 1. But this really is nothing else but 1 over x for x greater than 0 and 1 over x for x less than 0. Oops, sorry, I didn't mean to write that. I was looking at you when I was writing. Well, that's not good. No excuses. Right? Negative 1 over negative x times negative 1 is 1 over x. Would you agree? So now I am going to ask the following question, going backwards. What is the integral from 1 over x dx? Right. We're going to talk about this type of integral, but for now, remember, whenever we're asked to determine, well, I can put some, instead of writing this, I can put the integral from 1 to 2 from 1 over x dx equals natural log of the absolute value of x from 1 to 2. It happens that since x is between 1 and 2, I don't really need the absolute value, but the correct answer is the natural log of the absolute value of x. So please keep that in mind. In the next step, I would like us to work on another property of definite integrals. So let's look at the following scenario. I have a constant, uppercase m. I have another constant, lowercase m. And for the interval a comma b, I don't care outside of it, I have this function. Would you agree that it's okay, it's correct to write m less than or equal to f of x less than or equal to uppercase m on a comma b? I don't extend the statement outside of a comma b. I don't care. But I care only what happens between a comma b. Would you agree? This is not the squeeze theorem, but it's a function valued. All the function values are between these two. They're bounded. We say they're bounded. The function values are bounded by below by lowercase m and above by uppercase m on the interval a comma b. Then would you agree that this area under lowercase m must be definitely smaller than the area under the function, which in turn is definitely smaller than the area under uppercase m? Very similar to what we did last time. Would you agree with this? So then the integral from a to b from m dx must be definitely smaller than the area under f of x dx, and definitely smaller than the area under uppercase m. We accept this or not? This is another property of the definite integral. Of course, it's very clear this area is smaller than this one, the green one, and it's definitely smaller than the bigger one, the biggest one. Okay, we're asked to use this property or a property to show that 2 is less than or equal to this, which is less than or equal to 2 to the square root of 2. Let's give it a shot. So this is, let's copy what we're asked to show. We're not asked to calculate anything. We're only asked to show. So this is problem 57 on 384. 2 less than or equal to the integral from -1 to 1 from the square of 1 plus x squared dx, of course, less than or equal to 2 to the square root of 2. We cannot determine this integral, by the way. We don't have a tool to determine at this point in time its antiderivative. Okay, in such situations, where is our starting point? I can only start with what I know. And there is only one thing I know. I only know that x is between. That's all I know. I don't know anything else for now. I know that x is between -1 and 1. Excellent. I'm trying to build this function, so I have to look now at x squared. If a number is between -1 and 1, can you tell me what happens to x squared, to that number squared? The number is between -1 and 1. And if I square all those numbers, what is the range? What is the smallest number when I square everything between -1 and 1? What would be the smallest number? Of course. What would be the largest number? Exactly. Excellent. So if x is between -1 and 1, obviously x squared, one more time, will definitely be between 0 and 1. Excellent. So I built x squared. What do you think I'm going to do next to all three sides of this inequality, compound inequality? Exactly. So 1 less than or equal to 1 plus x squared less than or equal to 2. So now I built the inside. That's it's already there. Now, what do you think? Look at the function and say, oh, now I know what you're going to do. You are going to do blah, blah, blah. No, don't say blah, blah, blah. Just tell me what. Yes, I will apply the square root because all these numbers are positive. All these numbers are positive. That's why I can apply the square root. Otherwise, I would say don't. So the square root of 1 is 1, less than or equal to the square root of 1 plus x squared, less than or equal to the square root of 2. I have established this relationship. I have established that the function I'm interested in, to find its area under -1, between -1 and 1, is definitely between two different numbers. This number and this number. If m is less than or equal to f of x less than or equal to m, then what follows? What can I write next? Okay, what did we write here for the interval a comma b? Good. Very good. Of course, dx. So we found out that the function, if you want, is between 1 and the square root of 2. So then the area under 1 must be smaller than the area under the function, which must be smaller than the area under the square root of 2. We understand this. Good. There is nothing I can do to the middle part. This is carved in stone. But maybe I can determine the left and the right. Which function prime is 1? Very good. Thank you. Between -1 and 1. The square root of 2 goes in front. Which function prime is 1? Between -1 and 1. Very good. I plug in 1, and I subtract when I plug in -1. Square root of 2, I plug in 1, and I subtract when I plug in -1. How much is this? Excellent. How much is this? Times the square root of 2. And now I go back and see what they wanted. They wanted us to show that 2 is less than or equal to the integral, less than or equal to 2 the square root of 2.
So at what point do you like stop? At what point do you stop like?
I stop at the
how do you
function.
stop?
The function tells me what.
No, like because you found the integral of like the y. So like at what point do you stop?
You mean from here, here?
Yeah, like at
I
what
can
point?
determine this. If I can determine, I will have to determine it. If I can determine, I can. But the problem is telling me that this should be 2. So we got 2. The problem is asking us to show that this is 2 to the square root of 2. So I know at some point in time I have to get to the square root.
I'm just asking like at what point do you like stop? Like how do you stop? And then find the integral.
When I create the function.
Oh.
When I create the function in the middle, I'm done. There is nothing else I have to add, subtract, multiply. I am building the function. One more time. We start with x, then we build x squared, then we build 1 plus x squared, then we build the square of that. And I'm done. I can't do anything else. There is no need. I will destroy what I just created if I would add or subtract or multiply further. So my purpose is to create or build the function right here in the middle. Once I build the function, I'm done. I can't continue doing anything. Does it make sense? Great. Great question, actually. Very good. Moving on. I would like us now to go back to the fundamental theorem of calculus part 1, which we have not discussed at all. We looked at definite integrals and their properties. We evaluated definite integrals. We applied some of the properties to prove certain things, but we have not discussed the fundamental theorem of calculus part 1. So that's our next step. FTC 1. Fundamental theorem of calculus. Part 1. Now, do we remember what part 2 was telling us? Fundamental theorem of calculus part 2 did what? What did it show us or teach us? How to evaluate definite integrals, right? The f of b minus f of a. Finding the antiderivative and replacing x by b by the top limit, and then subtracting by when we apply, when we replace x by a, right? That was part 1. Part 2 will teach us something else. Part 2 will show, if you want, it shows that integration and differentiation are operations. I want you to come up with that missing word. So, fundamental theorem of calculus part 2 shows us how to evaluate the definite integral. But part 1, it shows us that differentiation and integration are exactly. They cancel they cancel each other out. So are inverse operations. Indeed, they are inverses. Like natural log and exponential. Like the square root and x squared. Okay, so let's illustrate this. Here's a function. Here is an interval. Can anyone tell us what this represents? All this area is the area. the integral from a to b from, very good. Indeed, that is a number. It's the exact area under the graph of f of x between a and b. We know that. Now, please pay attention. I'm going to do this. I'm going to say that x is any number between a and b. And I would like you to give me the area that is this. Only this piece. Yes? Excellent. Since I chose this x, allow me to change this into t. dt. Perfect. So you're saying that the integral from a to x from excellent. Indeed. It is the integral from a to x from f of x dx. F of t dt. Okay. But what does this mean? Do not answer before I give you some hints. So, assuming that the interval is, let's say, between 1 and 4, I hope you agree that if x is 2, we're going to get a number. So the integral from 1 to 2, there will be a number. If x is 2.1, I'm going to get a different number. If x is 3, I'm going to get a different number. If x is 3.2, I'm going to get a different number. If x is 3.5, if x is 3.9. So what does this represent then? Since x goes from a to b. What did I just create? Every time we have an input, 1, and we get a number, and we get another input, and we get another number, and we get to put in another value, and we get another number. What are we creating? With an input and an output, what do we always create? A function. So this, because x can be any real number between a and b, this is a function given to us in the form of an integral. So the integral from a to x from f of t dt is not a number, but a function. We're going to call it g of x. It's a function of x. X is the variable. X is going from a to b. So it is possible that a function is given in the form of an integral when the upper limit is x or another function, if you want, of x. So this is very clearly, let's write it one more time, g of x is a function from a to x from f of t dt. We're not ever asked to determine the integral. The only question that we may be asked to do here is find g prime of x. I have a function. I'm asked to find its derivative. The function is given in the form of an integral. How do I find g prime? I differentiate both sides. That's what I need to do, both sides. And let's see what we get. The left-hand side is what I'm looking for. But now, this is what part 1 says or shows. When you differentiate an integral, you get the function. You get f of x. And this is fundamental theorem of calculus part 1. Whenever we are given a function in the form of an integral, and we're asked to find its derivative, not calculate anything, but just find its derivative, this is what we need to do. But now, I should write times x prime times this prime. But I don't. Why I don't? Why don't I write x prime? Because it's 1. Now let me give you a very simple example. What if I have this from f of t dt? And now I'm asking you, find g prime of x. What will you do? You will proceed in the same way, but times the inner function prime, which will be 45x squared. So this is a function, one more time, given in the form of an integral. What is the purpose of it? To understand that differentiation and integration are inverse operations. When I differentiate an integral, I get the function. When I integrate a derivative, I get a function, or the function. Let's practice these situations. I want you to choose. Here they are on page 394. We have several situations. We have several functions, as you see. F of x, g of x, h of x. They all have x. Natural log t dt. In all these problems, we are asked to find the derivative of the function. No one will ever ask us to, if we have a function as a lower limit or upper limit or both, no one will ask us to evaluate this. It's a function. You have to give me x. If you give me x, I'll evaluate. But not the generic, right? So in this case, we're only asked to find their derivatives. So please choose, or I will. Okay, I would like to start with number 9. Let's see why it's in red. A word of caution. Fundamental theorem of calculus part 1 requires the lower limit to be a number. Any number. As you see, it doesn't even come into play. You cannot reverse these two. The lower limit must be the number. The upper limit, the sky is the limit. Whatever. Function or otherwise. But the lower limit must be a number. Okay? So, we're practicing fundamental theorem of calculus part 1. So in number 9, we have g of s equals the integral from 5 to s from t minus t squared, that's the function, t minus t squared, sorry, to the 8th power dt. Is it? Yes. T minus t squared Of course, we're only asked to find g prime of s. All I have to check is that this is a number, and it is, and this can be anything. And in this case, it's s. So can you please tell me what to write? times s prime, but there is no need. Is that clear? Perfect.
There's no need.
No, because s prime is 1, like x prime. Right? Right? Okay, 16. We have a function y, which is the integral from 0 to x to, I think it's x to the 4th, yes. From cosine squared theta d theta. Okay, so we're asked to find y prime. In other words, we differentiate this side and we differentiate this side. Maybe I should have written it here for you to see what we're trying to do. Okay, so what do I write? Cosine squared what? Of x to the 4th times the inner function prime. That's it. I would rewrite it with 4x to the 3rd in front, but that's it. What about 17? So now you know how to differentiate an integral or a function that is an integral. So the integral from 1 minus 3x to 1 from u to the 5th over 1 plus u squared du. Same question. We're asked to differentiate. However, I can't. Not just yet. It's not ready. The lower limit is not 1. The lower limit is the function, so I have to do this. But I know from last time that there is a property that allows us to do this, but something changes. What changes? Yes, negative. The integral from 1 to 1 minus 3x from u to the 5th, 1 plus u squared du. Now, I can differentiate the beginning and I can differentiate the end. Please tell me what to write next. So then what is y prime? What does y prime equal to?
You're differentiating both sides.
Of course. I differentiate this side and get g prime. I differentiate this side and I get this. I can never differentiate just one side. This is an equation. Y equals an integral. So when I differentiate the left-hand side, I have to differentiate the right-hand side. However, I was not able to differentiate this form because I had to swap first. So the left-hand side is y prime. What do I get here? Negative in front. What else? 1 minus 3x to the, yes, over 1 plus 1 minus 3x to the, good, times, say it again, perfect, times negative 3. So therefore the answer will be y prime is 3, parentheses 1 minus 3x to the 5th, over 1 plus 1 minus 3x to the 2nd power. You don't have to do anything else to this. So we were given a function in the form of an integral and we were able to differentiate it to find its rate of change if you want. Now things are getting a little bit more complicated, but not that much. Here's an example. 56. G of x is also an integral from 1 minus 2x to 1 plus 2x from t sine t dt. Again, the same question, we are asked to find the derivative. And you have to say, wait a minute, I can't. It doesn't have a number as the lower limit. I've never seen two functions like that. So I have to find a way of presenting this in a different way, or simplifying it somehow. So it's ready for differentiation. Right now it's not ready for differentiation. So one property that we discussed some time ago, last Monday, was this. The integral from a to b from f of x dx is the integral from a to c from f of x dx plus the integral from c to b from f of x dx. Awesome. Perfect. Well, this is our situation. So I will present the integral from 1 minus 2x to 1 plus 2x from t sine t dt as a sum of two integrals. One starting at 1 minus 2x and the other one ending in 1 plus 2x. So in other words, I am finding a break between the interval 1 minus 2x and 1 plus 2x. And I need to put a number in there. It's up to you what number you want to put, or nothing. It doesn't matter. It will not come into play anyway when we get to differentiate. If you want to put 0, put 0. If you want to put 1, put 1. If you want to put C, put C. If you want to put M, put M. It doesn't matter. So I broke up the integral into a sum of two integrals. From the lower limit, which is 1 minus 2x, to whatever, and from that whatever to 1 plus 2x. However, when I start differentiating, this is ready, but this one is not. But a few minutes ago, we had an example like this. What should I do with this one? Right. So I have to write the integral one more time, or the integrals one more time. So this will be negative in front, the integral from the number, whatever, to 1 minus 2x plus, of course, t sine t dt. T sine t dt, t sine t dt, of course, plus the integral from that number to 1 plus 2x, of course, from t sine t dt. And now both integrals are ready to be differentiated. And then g prime will be, help. What will be g prime? Negative in front. And then what? What do you think? Give it a shot. So I'm differentiating the left-hand side, and now I'm differentiating this. What do I write? Everything is the same. There is no difference. Plus. Excellent. Everything is the same. It's just that the limits of integration were functions. And I had to go through two different properties, apply two different properties of the definite integral to make this happen. So what now? Very good. Yes? Exactly. I will just rearrange it a little bit, and that's the derivative. So 2, 1 minus 2x, sine 1 minus 2x. I don't need the first parenthesis in here. Sorry about that. plus 2, 1 plus 2x, sine 1 plus 2x. That's it. This is the derivative of that function given in the form of an integral with limits of integration that are functions themselves. I think we should look at another one like this. Would you like to choose? Or I will. Yes, Felix, any questions?
Isn't 17 a cube?
I'm sorry?
7 over 17, the one we did before. I'm only saying it because,
You want to go back to
yeah,
17?
I think it's a cube. I know it doesn't change the problem, but under the equation.
Did I write something else in here? 16?
17. Yeah, it's a cube. It doesn't change the problem, it's just a little pretty precise.
Oh, at the top it's cubed and I wrote 5. Oh, I'm so sorry. My apologies. It is cubed. Sorry about that. Thank you. Thank you. Any questions? Would you like to choose another? Is it okay if we look at another one like this?
That's the final answer.
That's it. That's the derivative. It's a sum of two functions. Okay. Let's look at 57. And this is given as an uppercase f. It's okay. From x to x squared, from e raised to t squared and dt. Of course, we're asked to find f prime. We cannot be asked to do anything else but just differentiate. But we will say we can't right now. This function is not ready for differentiation. It needs prep, some prep. So what do you think we have to write before we differentiate? Perfect. Still not fully ready. This is, but this one is not. What are we doing next? So then we write equals, yes, negative the integral from the number to x e to t squared dt plus the integral from that number to x squared e to t squared dt. Now it's ready to be differentiated. So how do we write this? Negative indeed. Good. Times x prime, but that is good. Plus x squared squared, which is, yes, x to the fourth, times, that's it. In this particular case, I would not do anything. You can just put 2x in front of that first one. In front of, in front of the second term, but it doesn't matter. Do you think we need another example? Or are we in the clear with how we differentiate a function in the form of an integral? Would you like another, or we move on? Yes, of course. Let's take a look at 59. And I'll wait for a minute for you to work on it. 59 is y equals the integral from cosine x to sine x from natural log in parentheses 1 plus 2v dv. Okay, 2 minutes. I'll take attendance another time. Do we have an answer? Okay, so it needs prep, right? So I will have to change it into negative, the integral from a number to cosine x from natural log of 1 plus 2v dv, and plus the integral from that number to sine x, natural log of 1 plus 2v dv. Now it is ready for differentiation, so I can write y prime equals negative natural log of 1 plus 2 cosine x times negative sine x, awesome, plus natural log of 1 plus 2 sine x times, yes, cosine x. All I will do, I will change these into positive. So this will be sine x natural log of 1 plus 2 cosine x plus cosine x natural log of 1 plus 2 sine x, and that will be the derivative of the function given as a form of in a form of an integral. Questions? Are we okay with this? Perfect. I would like us to look at an application of this and see how we do it. I just need a pencil so I don't write on the book. 1 second, I have it here. I lied? No, I didn't. Okay. Ready? So here we're given in problem 3 or problem 2, it doesn't matter. Let's look at 2. So let's read the question first. Let g of x be the integral from 0 to x from f of t dt, a function in the form of an integral, where f is the function whose graph is shown. Evaluate g of x for x equals 0, 1, 2, 3, 4, 5, and 6. Let's choose one. It doesn't matter. Choose the one you like. Okay, so let's say 4. So we want to find the g of x which is the integral from 0 to 4 from f of t dt. Okay? So this is the area, right? We want to find g of x. Is the area between 0 and 4 under f of t. So between 0 and 4, this is the area. But this piece is positive, this piece is positive, but these two pieces are negative, and these are all the same. Half a square, half a square, half a square, half a square. 2 half of squares positive and 2 half squares negative. So what will be the answer for just for 4? 0. So that will be 0. Of course, if I change x, the answer will change. So let's look at, for example, choose another. Let's see what happens. Okay, so if you want to use 3, so if we want to use 3, then we have the area that is this, which means 2 negatives, which is 1, right? It's half a square of 1 by 1, but minus 1. So what will be the area will be a negative half a square. How much? Because these two annul themselves. So we only have a negative square or square under the x-axis. So the area for 3 will be negative 1/2. Right? 1 times 1 divided by 2. Okay, perfect. Okay, then we're asked to estimate g of 7. Okay, this is 7 right here. So g of 7 will be the integral from 0 to 7 from f of t dt. So then I have to add everything. It has an estimate because, as you see, it's hard to come up with this area. It's hard to come up with this area and also this area. Everything else can be easily determined, right? Can you see? So this with this will go away. This with this will go away. So basically, I have this piece, this piece, this piece, this one, this one, this one, this one, and this one. Because everything else goes away. This with this with this. So it's basically the area between 4 and 7 that I need to add. So I'm going to say 1 square, 2, 3, potentially 4, half. So 4 plus 1/2 plus 1/2. So I'm going to say another, right? This is 1, 2, 3, 4, maybe 5. And then I don't know how to estimate these two. That's not an easy task. So you may say that this is half. It's potentially, but it's maybe less than. I think it's less than half. And this one will be maybe about 80%. So I'm going to say this is maybe, it's not half. So it's less than half. Maybe 1/3 for this piece. Maybe hard, right? Like 80%. You want to raise 4/5? I agree with that too. So then I have to add these. So 5 plus 1/3 plus 4/5. And that would be the area between 0 and 7, which is to estimate g of 7. The integral from 0 to 7 from f of t dt. Okay, where does g have a maximum value? Where does it have a minimum value? And then it says sketch a rough graph of g. So that's why they're asking us to determine all these values. So then we have a point. For x equals 0, we have g of 0. Then g of 1, g of 2, g of 3, 4, 5, and 6, and also g of 7, and then we graph. So then we have to go back and determine all of them. But the question here is, where does g have a maximum value? And where does it have a minimum value? Okay, so let's discuss that. So So we are given a function. So this was problem 2 on page 394. So we're given g of x. Sorry, I forgot. So we're given the integral from 0 to x from f of t dt. And we were told that 0 less than or equal to x less than or equal to 7. So every time we find or try to find the max min of a function, forget about the fact that it's presented as an integral. Every time I want to determine the maximum or min of this function, what do I need to determine? Exactly, the derivative, right? Good. So when I determine the derivative, so g prime of x, what will I get in this case? Well, I get f of x. Right? Now, what should I do next if I had the information about the function? I don't have the information about the function. I will set g prime of x equal to 0, right? In other words, I will set f of x equal to 0. Where f of x is 0, in this case, g prime of x will be 0, and those will be critical numbers. But we don't have the information about the function. So still we're asked to find at which point does this function have a maximum or a minimum? Where does g have a maximum value? Where does it have a minimum value? So remember this, g, we had several, those options which we didn't determine, right? We did not determine g of 0. We did not determine g of 1, g of 2. We determined g of 3, roughly, what was it? We had 5, right? It was g of 3, correct? No, there was g of 7, sorry. G of 3 was 0.5, 1/2. G of 4, we determined g of 4. It was 0, right? G of 5 we did not determine. And we determined g of 7, which was 5 roughly plus 1/3 plus 4/5.
Keep through with negative, it's on my own.
Which one?
G.
Oh, yes, of course it matters. Oh, of course. Thank you. Yes, it was negative. Thank you. Okay. So when we look at the area on the graph, right? So we start with a positive value, but then we immediately subtract. So we start with a positive value, but then we subtract this. So obviously at 2, the area is 0. Then at 3, we determine it's negative 1/2. At 0 is 0, right? So from 0 to 0, this must be 0. So this is 0. At 1, the area is 1/2. At 2 is 0. And the only one that we're missing is to calculate g of 7, and we have to calculate g of 5. What was g of 5? G of 5 is 1, 2, right? 1, 2, and this is negative 1. So it's 2 plus 1 is 3. Let me check again. G of 5. So 1, 2, but minus 1. So it's 1. And 1, okay, I made a mistake. So it's 1 plus 0.5. So it's 3/2. 3/2. And then the last one, the least common denominator, if we come up with this is an approximation, a very rough approximation. So 5 times 15 plus 5 plus 12. So 75 and plus 17 over 15. So I got 92 over 15. One more time, 15 times 5, yes, times 5, times 3, correct. 75, 17, correct. Okay, so now, where is the area minimum?
How about G of 6?
Oh, we were asked, we also have G of 6, we didn't look at G of 6, you're right. Thank you. I jumped from 5 to 7. Let's look at G of 6. G of 6, 1, 2, 3, 4 and a half, 4, 4. Thank you. Can get away with anything in this class, and I don't want to. Thank you very much. Sorry about that. Okay, so now we have 0, 1 half, 0, negative 1 half, 0, 3 halves, 4, and 92 over 15. So where is the G minimum?
Negative half.
Yes, when x is 3. Very good. When x is 3, G is minimum. Where is G maximum? So when you divide 92, so that's
6.1.
right. So where is the maximum then? Yes, at 7. So this is the maximum, and this is the minimum. And now if you want to graph, we only have to plot these points. 0, 0, 1, 1 half, 2, 0, 3, negative 1 half, 4, 0, 5, 3 halves, 6, 4, and 7, this. And that will be the graph. It will be an absolute estimate, right? Because I couldn't even determine those. So this is an application of fundamental theorem of calculus part 1, in which we're given a function in the form of an integral. Okay. Finally, we are ready to talk about